challenge you a little bit.
So it would actually be 3 square root 2 over square root 39.
Okay, now you cannot leave your answer like this. Do you remember what you have to do from here?
Divide it.
You have to rationalize.
Rationalize it. So make
Yeah.
it 39 times 39. Just make it regular 39, and then make it 3 square root 678.
Okay.
And then I need to reduce that again, don't I? The 78.
Yes. Well,
And
what about on the bottom here as well? What is the bottom again?
39.
Okay.
And then I'll break up the 38. So 78, I'll do first 78 divided by 2. That's 39. 39 cannot be divided by 2. So I'll make that 39 divided by 3. That'll be 13. And so 13 is a prime number. And so I'll do 13 times 3. And that will bring back to 39. And then 39 times 2 bring me back to 70. Hold on. Where'd I go wrong? Where did I go wrong?
Are you sure the square root of 78 reduces?
No, it doesn't.
It does not. So you actually don't have to do anything with that. It is good that you looked into it, but it becomes 2, 3, and 13, which don't, they're all prime, no pairs. But the 3 and 39 does reduce.
Yeah, that one would be 39 divided by 3, which will be 13.
That's right. So this becomes the square root of 78 over 13. So sine t like that. Okay. Let's see if you do a little better job here in the next one, meaning just, please try to work these out fully. I don't know if you'll get anything like this. Maybe you won't, but something like that. Have we done 30, 60, 90 triangles?
Yeah, those are where it'll be x squared, x times 2, and then x square root of 2, right?
So the reference triangle here, let me not draw it let me draw it the sort of the standard way. So 30 degrees, 60 degrees. The short leg is x.
Mm-hmm.
The long leg is x root 3. Notice it's across from the 60.
Yeah, and then x 2, right?
2x for the hypotenuse.
Yeah.
All right, so let's say for this one, let's say I tell you that this is 15, and I want you to find x and y for me, please.
Okay, so I know the hypotenuse will be 30.
I am not giving you the short leg.
You're giving me the long leg.
Yes, you have to identify whether you're given the long leg, the short leg, or the hypotenuse. You can't just go by looks. Like even if this side looked shorter, it has to be across from the 30. That's the only way you can do it. Because I can give you a problem here where I tell you that this is 60 degrees. It's just drawn wrong.
Mm-hmm.
I mean, I don't know if your teacher would do that, but that's something to think about.
Okay, all right. So that one is actually that one that's x times 3.
Times square root of 3. Yes.
Times square root of 3.
Yes.
So then I got to do 15 divided by square root 3.
Yes.
I believe. Okay, good. And then so how do I do that? Can you explain how I divide them again?
Yeah, no, I appreciate you asking here. You divide by the square root of 3 like that. Okay. And the problem is that you're not supposed to leave square roots on the bottom. So you have to rationalize. And you're rationalizing the denominator, which means you're turning it from an irrational to a rational, literally. But the numerator becomes irrational. But that's a side point here. This becomes over 3. And then see how 15 divided by 3 is 5. 5 square root of 3.
So it'd be 5 square. Okay.
Okay. Now when I say x, though, that's not this x in this triangle. X in this triangle is the hypotenuse. So you have to remember that x is the short leg. What's the short leg in this picture?
The y.
Yes. So that's 5 root 3. What's the hypotenuse?
The hypotenuse is x.
Okay. And how do you get the hypotenuse from the short leg?
Double it.
Double it. So that's 10 root 3.
Yeah.
Okay, let me give you another one.
Okay.
Do you have this down? Like, are you able to generate this on the fly?
Yeah, I think
X,
I got
2x,
it.
x root 3. Okay.
Yeah, I think I understand.
Because you're a good math student. Like, I can't just give you one that's just like it. I have to switch it up each time, or you're going to
Catch on.
yeah. All right, so let's say this, we'll do it like this. I want you to find B and C in this problem, please.
Okay, so that one is, we're given the long side, which will be
The
divided by
hypotenuse.
2.
Yes.
Yeah. So I will turn that into 7 square root 6, which will be the short leg.
Is that B or C?
B.
Okay. How do you find C?
And then that I multiply by 3, which would be 7 square root 18.
Is that your final answer?
Nope. It will actually be 21 square root 2.
Okay, so now I'm going to call this big B. I want you to find the sine of big B for me, please,
Okay.
and reduce.
Okay. 7 square root 6 over 14 square root 6.
Okay. What does that reduce to?
7 square root 6 over 14. 2.5 square root 6.
If it's the same on the top and the bottom, it cancels.
Oh, so just be 0.5 then.
1/2, yeah. Now give me the cosine of B, please.
Cosine of B, that will be adjacent over hypotenuse, which will be 7 square root 18 over 7 square root 6, which will be square root 3. Correct?
You said the adjacent is 7 square root 6? The adjacent is C.
Oh, so it'll be the other way around. It'll be
Well, what's
7.
the adjacent? What's the value of C in this problem?
7 square root 18.
I see, you're trying to do it that way. Okay, what is the
So both
hypotenuse? What is the hypotenuse?
14 square root 6.
Okay, so what is this?
So I know that's going to be 0.5 square root 3.
Okay, or square root of 3 over 2. Good, almost there. Let's do the tangent of B.
Mm-hmm. All right, so then that one will be opposite over adjacent, which will be 7 square root 6 over 7 square root 18, which will just be 1/3.
Try again.
1/3, right? Wait, no, hold on.
Well, it's 1/3, but it's inside parentheses. It's
Square
inside
root, yeah, square.
Okay, so you can't, so you cannot leave your answer like this. You have to take the square root of the top and the square root of the bottom. What does that become?
Oh, uh,
What's the square root of 1?
just 1.
Okay, can't leave your
Square
answer
root
like
3.
this. How do you make this answer better?
I'm not too sure.
Rationalize. You cannot leave a root on the bottom.
Oh,
You have to stare at this and say, I don't like this because there's a root on the bottom. You'll be doing this next year when you take calculus, when you do trigonometry, geometry. Well, you're in geometry. When you do like algebra 2 trig or pre-calculus, you'll do this. You'll have to rationalize when you're calculus. You have to rationalize when you're taking physics. You'll have to rationalize. So you need to stare at this and say
okay.
that doesn't look right.
Okay.
So
All
what is your new answer here?
right. 1 square root 3.
Over.
3.
Yes.
Okay. That makes more sense.
Okay. Now, just to summarize here a little bit, B was 30 degrees. So there's actually some important. So that they sometimes do this. There'll be theta, beta, and we'll fill in this table here. When theta is 30 degrees, sine, cosine, and tangent, we just got some really important values here. The sine is 1/2, the cosine is the square root of 3 over 2, and the tangent of theta is the square root of 3 over 3.
Okay.
And you may end up having to do this for like 60 degrees. We're going to actually do it for 45 next because we're going to look at a different type of problem here.
Okay.
Okay, this is the kind of a typical test question though, to maybe have to fill in a table like this.
Okay.
All right, so let's look at another triangle here. Not to scale. Let's say that this is 15 square root of 12, and I want you to find y and z.
So are these equilateral triangles?
It is not equilateral. It's a right triangle, not drawn very well. I can draw it better if you would like, but that's a right angle down there. These two sides are the same. This is a 45, 45,
45.
90. So do you remember
So
that? Do
those
you remember?
it'll be times the square root of 2.
Yes.
Okay. All right. The answer will be 15 square root 6.
For what?
Y and z.
Okay, I agree. All right, so let's make this a. I want you to tell me the sign of a fully reduced, please.
Okay.
That means you may have to rationalize.
Okay. Well, it'll be 15. No, hold on. Yeah, 15 square root 6 over 15 square root 12, which
Okay,
will
keep
just
going.
be 2 square root 2.
You ever watched Family Feud when they get the wrong answer? Do you remember I don't know if you've seen that, where they give the buzzer the zzz. Close. You're really close, right? And you said the right things. I mean, again, my perception is maybe you're not writing much down here, because yeah, it's there's kind of a 2 in here, but the 15s cancel, and it's the square root of 6 over 12. You can rewrite, and that becomes the square root of 1/2.
Oh,
This is not 2
okay.
though. It's not even close to 2. It's. I mean, there's a 2
And
in
it'll
there.
just be one square root 2.
Okay, but this is also a problem. You have to look at this and say, I don't like that. Now you may not know why yet, but you have to, in mathematics, the more math you take, you have to sort of follow these guidelines, which is you don't leave square roots in the bottom.
Okay.
So can you rationalize this for us?
1 times square root 2?
That's right. Over what happens at the
2.
bottom?
2.
Yeah. So just to be clear, here's what I was hoping you were going to tell me after going through all the work. I wanted in the box here square root of 2 over 2.
Oh, okay.
All right.
Right.
So next here, I want you to find the tangent of B. Tangent of B, please.
All right. So then that will be adjacent over square root over. It will be the same thing.
Try again. TOA.
Oh wait, no. Wait, no. It's opposite over adjacent, which will just be 1.
It is 1. How about the cosine of B?
Square root 2 over 2.
Yes. So if we go back to our table here, the sine is always the square root of 2 over 2. Cosine is the square root of 2 over 2, and the tangent is 1. We talked about this, I think, a little bit, but I think we did it in terms of like a 3, 4, 5 triangle, where I said the cosine of A, which is 3/5, equals the sine of B, which is 3/5. Do you see that in this triangle?
Yeah, I sort of remember
You see,
it.
well, adjacent over hypotenuse. B is
Yeah,
opposite.
it'll be half, right? One is half of 1, and 1 is square root times 3.
No. This is just a generic triangle. This is just a nice Pythagorean triple triangle. 3, 4, 5. Cosine of A. Do you agree Do you agree that the cosine of A is 3/5 adjacent over hypotenuse?
Yes.
You seem uncertain. What are you struggling
Uh,
with?
um,
Try to
I'm
verbalize.
just I'm mapping it out in my mind right
Okay.
now.
And how about the
Uh,
sine of B? Let me know if you,
Sine 1/5.
where are you getting the one from?
Wait, no, that'll be 4/5.
Sine is opposite over hypotenuse.
Yeah, so it'll
Opposite,
be
opposite of B.
opposite of B. Yeah, three over
Yes.
five. Cosine of A would be 3/5 also.
Yes. So do you agree that these are the same as I was trying to get you to see?
Yes, I do.
Okay. Now, we don't know the angle measure of A, but do you agree that B is 90 minus A? Like whatever A is, B is 90 minus it because the other one's 90?
Yes,
You seem uncertain again.
I'm kind of confused.
What do the three angles in a triangle add up to?
360? No, 180.
180. So if this one's 90, what do the other two angles have to add up to?
90.
So if you solve this for B, do you get B equals 90 minus A?
Yes.
Okay. So the sine of 30 equals the cosine of 60. Sine
Okay.
of 30 equals the cosine of 60.
Okay.
Now let's go back to your triangle up here and just verify that real quick here. Ooh, that was not the one we did. Okay, so we did, sorry, I'm losing my place here. If this is 60, okay, the sine of B is 1/2. So this should be equal to the cosine of A. Cosine of A is 7√6
Mm-hmm.
over 14 square root of 6. Is that still 1/2?
Yes.
Yes. Now this is not a proof, but this is me trying to explain it quickly. The cosine is the cosine of 30 is the sine of 60. The tangent of 60 is doesn't really have any relationship. It's actually the reciprocal of this number.
Oh,
Or I'm
okay.
sorry, it's not the reciprocal. It's something else. You may want to consider memorizing this for your table. You will need to know it in the next part of the course at
Okay.
some point. All right.
All right.
So try to keep in mind, here's what's in your toolbox right now. Pythagorean theorem. A squared plus B squared equals C squared. Then there's the special triangles. The first type are the triples. That's like the 3, 4, 5, the 5, 12, 13, and so on.
Mhm.
There's also the 45, 45, 90s, and the 30, 60, 90s. And then there's also the sine, cosine, and tangent that we've been working on.
Okay.
All right. Well,
All right.
we got another lesson on Thursday, so we'll just
On
pick up here.
Thursday?
Yeah,
Okay.
6 o'clock.
All right.